There are no jawless fish in modern times or in the fossil record which possessed a pelvic fin or girdle. This appears with the jawed vertebrates, the gnathostomes, as is evident here in the pelvic fins of this shark and in the pelvic fins of this bowfin. In the early tetrapod Ichthyostega, the pelvis now consisted of three separate bones: an ilium superiorly, a pubic bone projecting forwards, and an ischium projecting rearwards. And these would be the three bones of the os coxa for later tetrapods. The pelvic girdle of salamanders and frogs are composed of an ilium, ischium, and pubis. In frogs, the ilium is quite elongated. And the pelvic girdles of reptiles would continue to possess the ilium, ischium, and pubis. As is evident in this turtle, note that the pelvic girdle has migrated within the shell, and in this alligator. In the alligator, the pubic bone projects forward, the ischium projects backwards, and that was the case in the saurischian dinosaurs like Tyrannosaurus rex. In dinosaurs, both the pubic and ischium bones became elongated, and the hip socket, the acetabulum, no longer had a bony back. In birds, which descended from theropod dinosaurs, the pubic bone rotated so that it pointed posteriorly, but both the pubic bones and ischial bones are still elongated. As synapsid reptiles evolved into mammals, the hip was modified. The ilium enlarged for increased muscle attachment. The hip supported an upright stance of the leg, and the obturator foramen developed. These are evident in the hips of modern mammals, such as the platypus here, the cat, and the monkey. The human hip is composed of the same three bones, ilium, ischium, and pubis, found throughout tetrapod hips, and possesses features typical of mammals, such as an acetabulum, the hip socket, an obturator foramen, and a number of shared muscle attachments. And the auricular surface, where the ilium attaches to the sacrum of the vertebral column so that the legs can support the weight of the body. The characters of the human pelvis have been critical not only for the evolution of our bipedal stance and upright running, but also the size of the head of infants born at childbirth, determined by the size of the pelvic inlet.